This video is the start of a development journal for a couple of projects I've been working on. And the projects are kind of two halves of the same thing, which is that there's there's the game itself, which is an ultimate frisbee game. That's sort of the motivating project, and then there's the technology underneath it is kind of the other piece, which is sort of what I wanted to study in the first place, but I needed something on top to sort of motivate the development of it. So I'm going to talk about both things. I guess I'll start off with just the game itself. And so if you don't care about ultimate frisbee, you can skip ahead. And then later will be the technology. So if you don't care about that, you can just tune out then. But anyway, I've made an ultimate frisbee game before. It was an iPhone game released around 2009 or 10, I believe. And it was okay. I think probably some people watching this have seen the game. It was pretty simple in a lot of ways. And for this one, I wanted to add a lot of things just to increase the complexity of it and make it more similar to an actual game of Ultimate. So just quickly, what you see here is obviously a very graphically simple game, and it's not supposed to look like much at this point, but you can see kind of the outline of a field. You have some players, these are the white squares, and then the disc is just a blue square on the ground. But I'll show you right now. I'm in editor mode. As you can see at the top, it says editor, and when I take it out of editor mode, I'll tell you what that means. But basically the players are going to run around a little bit. So that first player will go pick up the disc, and then he turns yellow, and the other players will start cutting for him. And you can see they kind of clear out to the side, and then cut in, make big in cuts, and cut deep. There's a little weird pattern in their cutting right now, which I have to fix up. But yeah, they move around roughly similar to how an ultimate player would. And one of the first things you might notice about this game is that there's actually acceleration in the running. So in the first game I made, the players would just go from 0 to 60 basically. If you told them a direction to run in, and they would just instantly start sprinting that way without having to accelerate. And they wouldn't have to slow down either. They could just stop on a dime, turn on a dime. And when I was thinking about making a new game, I basically realized that acceleration is a huge part of why Ultimate works the way it does. That if you don't have to slow down when you're making your cut and you don't have to speed up, then a lot of the cutting strategy just goes out the window. You don't really have to fake cut. You don't have to fake out a defender. You just instantly accelerate wherever you want. So I thought that was a really key component of any improved game, which is why I added it in. I guess I can keep going. And the other thing I wanted to do was on the AI side. I wanted the players to be a lot more sort of reactive, a lot more intelligent, so they can sort of make decisions on their own. So in the old game, the players just sort of run on a script, right? There was a scripted offense, and they would just run through them. And in this game, instead of running on a script, they will just continually make decisions about what they should do. And I can kind of demonstrate that by just clicking it into editor mode. And in editor mode, I can drag around the players. So I might move the player with the disc over, let's say, to a shallower part of the field. So now that the cutters are a lot farther away. Well, they can, if I unpause it, they're just going to adapt to that. So now they're gonna cut in farther. They're gonna start clearing to a different part of the field, and their deep cuts again will go to kind of a shallower part. And you know, I can drag this player even over there, and they're gonna adapt to what sort of cut should they make, should they clear out or whatever. And again, it's not perfect. They're doing some weird things here and there because it needs work. But that's basically the idea, that you should be able to drop them anywhere on the field at any time and have them do reasonably intelligent things. Let's see, is there anything else to say about the game? So obviously the game's really simple at this point. Yeah, they can't even throw the disc yet. That's something I will add, obviously. And the graphics are, of course, simple and terrible. But I definitely want to get the kind of the physics of the game down first, some of the AI first. And I want these players to really act like Ultimate players should. All right, so now I want to talk a bit about the technology behind the game, which I think is really interesting. And before I get into the details, I want to show one of the primary benefits of everything I've done, which is that as the game is played, I save the state of the game after every frame. And I'm basically recording the whole stack of state changes so that at any time I can travel back to any previous state. So for instance, I'll let the game run a little bit. Okay, the guy runs in, gets the disc, and the other cutters start cutting. At any time, I can pause this and go into a debug view. And obviously at the top, there's some information spit out about where the players are and, basically the whole state of the game here. But then I can, using the arrow keys on my keyboard, I can step back in time, and if I hold it down, the players are going to be running backwards. Okay, I can step back, I can go back forward, I can step back a little quicker or go forward quicker, etc. Which makes it's so easy to debug things. Like there's some cutting behavior, for instance, like there's a little weird, let's see, after they cut in, there's a little weird hitch in their clear out cut where they go deep for a second before they clear out to the side. Well, that's kind of weird. It's not really what I want. But I can actually look at the state of the game here, and I can also dump it out and then load it up into a debugger. But I can basically step back in time and examine the state of the game where there's something going wrong. And then from any state, I can play it from there. Yeah, so that's something really fundamentally interesting about this. And not only does that debug portion wrap the game, it also wraps the editor. So if I go in editor mode and then drag this player around like this and then put him up here, if I go into debug mode and rewind, I'm actually going to be rewinding those editor movements where I'm dragging it around. So I can drag it. So as I go back in time, it's just going to drag it around in that circle or back again. Which is all really interesting. So beyond that, I'm going to talk more about this in some kind of blog post or something. But the game is basically built up in layers. So every game has some sort of loop where you pull an input from the player, either from the keyboard or a mouse or on a phone, the touchscreen, and then you process it in some way. You apply it to your game data, maybe step forward the game data or step forward the physics and the AI and so on, and then render it in the end. And this is often not that easy to design well. There are a lot of different pieces in a game, and you have to get them to all fit together and update the data in a nice way and get the code to be structured very well. And it's often not very easy. But I've been trying to work on a way to sort of do this all functionally. And this bit of code here I have at the bottom of the screen. This is all Haskell, by the way. But at the bottom of the screen, I have this run layers function, which is sort of the main loop of the game. And I just want to show that it's very simple in that it actually isn't the loop. It runs one frame in the game, I should say. It's very simple in that it has these three layers that are just functions that are composed together. This dot there is just the function composition operator. So you can see that it's really just three functions composed together. There's a debug layer function that's at the top, and that processes any keys and applies it to the debug state. So my left and right arrow keys here, that's what that layer is going to process. The next layer is the editor layer, which obviously if it's unpaused and it's an editor, any dragging the players around, that processes the mouse movements there, and then changes the editor state. And then At the bottom of the stack, you have the game layer, which actually it takes a time delta and actually runs the players around or steps forward the AI or the physics and so on. So it's obviously it's very easy to see the structure of a program. It's like a pipeline almost, and it shows up right there at the very top level where you compose these layers together. And I'm going to write up how exactly I've been doing this, but it takes some ideas basically from, there's a lot of work these days on things like React, like Facebook's React project, or the Elm language, how they want to structure their application architecture. So it takes ideas from there and sort of generalizes it to the next level, where you have these layers of immutable states that you're sort of wrapping on top of each other and then updating all at the same time by running some input through it. So anyway, I'll have a blog post about that. But yeah, I just want to show these things, and more updates to come, and hopefully next time it'll even look a little bit nicer, although that's definitely not a high priority for me right now. All right, see you later.